Hello viewers, I'm Kausalya. Today we are going to solve problems related to star delta conversion. The problem is for the passive circuit consisting of resistances as shown, calculate the equivalent resistance between the terminals A and D. So this is your given network. We need to calculate the total resistance between the terminals A and D. Right. So here when you observe the diagram you see, so this is a delta connection, right? So now we are going to convert this delta into star, which makes our calculation pretty easier, right? So as usual, what is the formula? That is, you just make a guess here. We are going to convert this delta network into a star network like this, right? So again, what is the formula to convert delta to star? So here the formula is RAB into RAC divided by RAB plus RBC plus RAC. Again you see here all the three resistors have the same value, which makes our calculation further more easier, right? Because the value of RA, RB and RC will be the same. So value of RAB is 12 and RCA is also 12 and remaining this RBC is also 12. So just substitute the values and the answer is 4 ohm, right? Now similarly RB is also equal to 4, RC is also equal to 4 because here all the values of the resistors are 12, right? Now just we are redrawing the above circuit, right? So redrawing is, you see here, this 8 and 4 ohm remains the same, right? Now instead of these three resistors we have drawing a star network. So this is your respective star network and here we are having this 8 ohm and this 4 ohm as usual, right? So again this is your terminal A and this is your terminal D. We need to calculate the total resistance between AD, right? So again when you further simplify, so from this diagram you see again these two resistors are in series and these two resistors are in series, right? So 4 plus 8 will give you 12 and this 4 plus 4 will give you 8. And again when you look at this diagram, these two are in parallel because you see the current gets divided at this point. So the combination of this resistance comes in parallel with this resistance. So you see this 4 ohm is drawn here as usual, right? And this combination is like this, okay? This becomes modified as 12 and this becomes as 8 and those two resistors are in parallel. So how to find the total resistance of parallel combination? It's again 12 into 8 divided by 12 plus 8, that is equal to 4.8 ohms here, right? So this becomes 4.8 ohms. So this 4 ohm as such and this combination gives 4.8 ohms. So that gives a total resistance of 8.8 ohms, right? So this is the end of our first problem. We will proceed with the second one. For the network shown in figure below, find the equivalent resistance between the terminals B and C, right? So from this diagram you see we are having a delta network and a star network. The first step is we are going to convert this star into delta here, right? So converting star to delta. So again what is the formula? As we all know, delta means we need to calculate the resistance RAB, RBC and RAC. So here you see the formula is RA into RB, RB into RC, RC into RA divided by RC. Here everything is of 1 ohm. So just substitute it. So here the value of RAB is 3 ohms here. Similarly, RBC is also 3 ohm and RCA is also 3 ohm. Right. Now the star has been converted into delta. So when you redraw the circuit, you see here you will be having the values like this. That is, you see this 3, 3, 3 remains the same. Now this star has been modified into delta, right? So this 3 ohm, okay, comes in parallel like this. That is, you see the star here gets modified into delta, and that respective ohms becomes parallel like this. That is, these two resistors are parallel, again these two, and finally these two are in parallel. So again, when you calculate the total resistance, and you see, you can easily do this one when you have two resistors of same value and when they are connected in parallel, then the equivalent resistance is its half value, that is 3 by 2 is 1.5, right? So that is its equivalent resistance value. So here between AB again it is 1.5, AC 1.5, and between BC also 1.5. We need to calculate the equivalent resistance between B and C, right? So now reduce this resistors. Again these two resistors are in series. So 1.5 plus 1.5 gives you a value of 3. Between B and C, I am having a 1.5 ohm here. Right. Now to calculate the total resistance, again, this is a parallel combination, right? So therefore, R1 into R2 divided by R1 plus R2. So here 1.5 into 3 divided by 1.5 plus 3. So that gives the answer of 1 ohm. Right, the effective resistance between B and C terminal is 1 ohm here. Second problem gets over here. We will proceed to the third one. The problem is find the equivalent resistance between A and B. Again here we are having the terminals A, B. We need to calculate the equivalent resistance. So when you observe the diagram, you see here whether we are having a delta network or a star network. Here we are having a star network because to a common point, you see here we are having 3 resistors connected together, right? So the first step is we are going to convert this star network to delta, right? So when you convert the star to delta, you see our diagram gets modified like this. That is, these 3 resistors are replaced by these 3 resistors in this arrangement, and here this 9 and this 9 ohm are present as such, right? 9 and 9. So how to convert this? So again this is your formula, right? RA into RB plus RB into RC plus RC into RA. So when you substitute the values, we are getting the answer as 27 ohms. Since all the 3 resistors are of 9 ohms, you see they have the same value. Here we are having the equivalent resistance of the same value, right? The same 27 ohms here. So the next thing is, now you see here I am telling that these 2 resistors are in parallel. Can you accept? You see I'll explain why. Again you see one end of 9 ohm is connected to node A. Again one end of the resistor 27 ohm is connected to node A, right? And again the finishing point, you see the other end of 27 ohm is connected to this point, and similarly the other end of the 9 ohm is connected to the same point. Therefore these 2 resistors are said to be in parallel. Since this 27 ohm resistor one end is connected to A, but whereas the other end is connected to B. Therefore, these 2 resistors are said to be in parallel, and again when you just observe, you see this 27 ohm and this 9 ohm are in parallel because one end, that is one end of 27 ohm and one end of 9 ohm are connected together at a common point. Similarly, one end of 27 ohm and one end of 9 ohm are connected at the same point here, right? Therefore, you see these 2 resistors are in parallel, and again these 2 resistors are in parallel. So when you find the equivalent resistance, you see 27 into 9 divided by 27 plus 9. So that gives the answer of 6.75 ohm here. So this combination reduces to 6.75 and this combination reduces to 6.75, right? This 27 ohm, it remains the same. So again when you redraw the circuit, you see here this 27 ohm remains the same, and now these two 6.75 resistors are in series. So when you combine 6.75 plus 6.75, so that gives the answer of 13.5 here. Now this combination resistor comes in parallel with this 27 ohm resistor. So just when you multiply, okay, when you solve, finally the resistance value becomes 9 ohms here, right? So Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.